Hello, welcome to the lecture course CH-102 Organic Chemistry for F.Y.B.Sc class. So in last lecture we have discussed about the conformational isomerism in ethane molecule. So in this lecture we are going to discuss about the conformational isomerism in n-butane molecule. So if you consider the n-butane molecule, CH2, CH2 and over this CH3 and CH3. So 1, 2, 3 and 4 carbons. Okay. This is the n-butane molecule. So last lecture we have discussed the conformational isomerism in ethane. So ethane contains 2 carbons. So from each carbon, if we replace the one hydrogen by methyl group, that time we get the n-butane molecule. So this n-butane molecule also called as the di-substituted ethane molecule. What do you call? Di-substituted ethane. So here in this conformational isomerism of n-butane, we consider the rotation along C2 and C3 bond, and for our convenience we consider the dihedral angle between two methyl groups. So with the help of model we can get the ideas here. This is the methyl group, this is the carbon number 2 and carbon number 3, and again this is carbon number 4, 1, 2, 3 and 4. Okay. So, for our convenience, we consider the dihedral angle between two methyl groups, and this C2 and C3. Over this bond, we show the rotations, and because of these rotations, we get the different conformation of n-butane. You know that we can rotate this C2 and C3 bond from 0 to 360. Because of this rotation we get the different conformations in ethane. Same way we can rotate here bond along C2 and C3. Because of that we get different conformation of n-butane. So firstly, this n-butane molecule consider in Saw's formula. So this methyl group above the plate we consider here, then like this. So 1, 2, 3 and 4. How many carbon? 4 carbon. So in this way we can write the Saw's formula of n-butane. So this same molecule we can write in Newman projection formula. Suppose carbon number 2 is the front and carbon number 3 is the rear. So this is the front carbon and this is the carbon number 2 is the front and this is the carbon number 3 is the rear carbon. So carbon number 2 is the front. So along this carbon number 2 have the group with CH, okay, and rear carbon have also group like methyl, H and H. So we can write this kind of Newman projection formula for n-butane molecule. So for this zero dihedral angle, you know that very well. Dihedral angle is nothing but angle between two non-bonding groups or two non-bonded hydrogen is nothing but dihedral angle. Here zero dihedral angle between two methyl groups we can observe. So dihedral angle is 0. So this conformation is the first conformation at dihedral angle that is possible for the. So this is the first conformation isomer possible for n-butane. Secondly, if you rotate by angle 60, you know that we keep one carbon fixed, and if you rotate the back carbon by angle 60, suppose like this situation. So if you rotate the back carbon by angle 60 like this. So we get this kind of conformation. So angle 60 rotation, we get this conformation. So we write here this conformation, methyl group, then H. So because of rotation here, methyl group come at this position, then H and then H like this. If you from front, that time we get this is the angle 60. For this angle 60, we can observe this conformation. Okay. Then again angle 60 rotation. So 60 plus 60 that become that angle is a 120. How much? 120. For this 120, so if you view from front, so like this, so we get this kind of conformation. So in this conformation, if you view from front, so this is the front carbon in that group as it is here, but back carbon groups, this group come at this position methyl, then this H come at this position H, then this H come at this position like this. Means here methyl group come at this position by angle 60. Okay. Here methyl group come at this position by angle 120. So angle 120 we get this kind of conformation. Then 120 plus again 60. So 120 plus 60. See here. Because of that again 60. So we get this conformation. In this conformation, we can observe that this angle between these two methyl group is how much? 180 degree. So here, again we write here Newman projection formula for this. So methyl group. So this methyl group come at this position. How much? By angle 60. So overall, how much? That is the 180. So 180 rotation we can observe here. Angle 180. So we get this conformation. Next is if we rotate again angle by 60, we get again here angle is 180, angle 240 we can observe. For 240 angle we observe the next conformation, methyl group H as it is. So methyl group come at this position here, real carbons methyl group come at this position. Okay, methyl group come at this position, rear carbon methyl group come at this position, then H and this H. So overall this methyl group rotate from this to this position by angle 240. So that angle how much? 240. So in this way we can observe so see here, this group is come at this position. So overall angle is 240 to this. Overall angle is how much? 240 degree. Okay. So angle is 240 diagonal angle. Again 240 plus 60. So that comes out to be how much here? So methyl, then H and H. So this methyl group come at this position, then H and then H. So again angle 60. So this angle is how much here? 300. How much? 300 degree. So from this to this rotation we get the 300 that angle. For this we can observe this conformation. Okay. And last is remain, that is the again by angle how much? Again 60. We get again this kind of conformation. So angle 0 or 360, for that we observe the same conformation. That is the methyl H and H as it is. So rear carbons groups are changed here. So that group, methyl group come at this position, then H and this H. So the overall methyl group come to to this position by angle 360 overall. So diagonal angle 360 like this. So in this side we can observe the rotation along C2 and C3 bond, and because of that this rotation we get the different conformations in n-butane. So for angle 0, that time we get the conformation. That conformation have the name. Before that you know very well that is the in ethane molecule only two conformations possible, that is the eclipse and stagger. Okay. So depending upon neighboring group hydrogens, maximum close to each other or away from each other. In that way we can observe the two conformations, that is the eclipse and stagger. But here we can observe the four kind of conformations, four types. First is a fully eclipse conformation, then partially eclipse conformation, skew or gauge conformation, and last is a staggered conformation. So these all four conformations possible here. So first is a fully eclipse conformation. What do you call fully eclipse conformation? Okay, this is the first conformation. So this fully eclipse conformation can be possible for angle 0 degree, also for 360. We can observe the same conformation, that is fully eclipse conformation. Okay. So for angle 0 and 360, for that we can observe the same conformation as fully eclipse conformation. Then second conformation for angle 60 we can name that as skew or gauge conformation. Skew or gauge. So this conformation also possible for angle, that is the 300. For this we can observe the skew or gauge conformation. So angle 60 and angle 300. For these two angle, for these two diagonal angle we can observe the skew or gauge conformation. Okay. Then angle 120. For this we can observe the conformation that name have the name angle 120. Okay. Partially eclipse conformation. Okay. So partially eclipse conformation also possible for this partially eclipse conformation. So for angle 120 and for angle 240, for these two angles we can observe this conformation. Angle 120 and angle 240. For these two angles we can observe the partially eclipse conformation. And for this angle 180 we can observe the staggered. What is called staggered conformation? Staggered also called anti-conformation. What we call staggered or anti-conformation? This is possible for angle theta, that is the angle 180 degree. For this we can observe this conformation. So one by one we are going to consider these conformations here. That is the fully eclipse conformation, then skew or gauge, then partial eclipse and anti-conformation. Okay. So this is the angle 0 or 360. For this we can observe the which conformation? Fully eclipse conformation. In this conformation, the angle between two mixed group is 0 or 360. So we can fully eclipse for this. So in this conformation we can observe that these two mixed groups here. So diagonal angle 0 or 360 in this in that situation. We can observe that these two mixed groups, they are show the eclipsing kind of interaction. Means mixed groups show the eclipsing kind of interaction. Also this neighboring hydrogens, we can observe that they are also eclipsing. Means these two, also these two here, these two and these two also eclipsing. Means here these two also eclipsing mixed groups. Also here these two neighboring hydrogens also eclipsing each other. Also these are eclipsing to each other. So because of that, you know that very well. Because of this, when these groups are maximum close to each other, that time they show the non-bonded torsional interaction. So because of non-bonded torsional interaction, energy content of this conformation is very large. Means energy content is very large. So because of that, this is the fully eclipsed conformation. We can call that this is the most unstable, most unfavorable conformation of n-butane. What do you call? Most unstable, most unfavorable conformation. So also this methyl group show the which interaction, steric interaction, and because that energy content of this conformation is very higher or very large, so the energy content of this conformation is given as 4.4 to 6.1. How much? 4.4 to 6.1 kilocalorie per mole. So in this range we can observe the energy of this conformation. So we can get adder from this model also. See here, methyl group are eclipsing, also these two hydrogen is eclipsing, also these two hydrogen are also eclipsing interaction. Because of that, energy content of this conformation is very high. Second conformation, Q or Gauge conformation. So in this conformation, we rotate the back carbon support by angle 60. So here, when relative angle between two methyl group is 60, that time we call the skew or Gauge conformation. So this two methyl group actually show the Gauge interaction, or we call Gauge interaction. So for angle 60 or for angle 300, we can observe the angle between methyl group is 60. How much? 60. Here also 60. So this is the called as which conformation? This is called as skew or Gauge conformation. So in this conformation, we can say that these two methyl group actually show the Gauge interaction, and because of that, this conformation have the energy at the 0.8 kilocalorie per mole. How much? 0.8. Actually, methyl group also angle is 60. Also methyl group have the angle 60. Here is also the same situation. Angle is 60 between the methyl group. Between the hydrogens. Between the methyl group the angle is 60, but between the hydrogen the angle is 60, also 60, also 60. So hydrogens, when relative angles between neighboring hydrogens is 60, that time did not show the Gauge interaction. Their Gauge interaction nearly equivalent to 0 kilocalorie per mole. But when methyl group show the Gauge interaction, that have the energy at the 0.8 kilocalorie per mole. How much? 0.8 kilocalorie per mole. Because of that, we observe the energy content. 0.8 kilocalorie per mole for this conformation. Okay. So this is our Gauge or skew conformation. Next is the, if you rotate the angle again 60, so relative angle between these two methyl group is the how much? 120. In that situation, we call partial eclipse conformation. So same situation we can observe for the angle 240 also. So in this situation, we can observe that in conformation, that is the CL. This methyl H, they show the eclipsing kind of interaction. Also this methyl H show the eclipsing kind of interaction. Also this HH show the eclipsing kind of interaction. So in this conformation, that is the partial eclipse conformation, two methyl H interaction, also one HH eclipse interaction. Because of these things, this partial eclipse conformation also energy content value is given here, and the energy content is given 3.3 kilocalorie per mole. How much? 3.3, nearly about 3.4 kilocalorie per mole. In this range, we can observe the energy. So why? Because we can observe from this model also this methyl and H. This also shows the eclipsing kind of interaction. This H and this also methyl group show the eclipsing kind of interaction. Also this H and this H. This show the eclipsing kind of interaction. So overall in this two methyl H and one HH, that interaction is present. So because that energy content is nearly about 3.4 kilocalorie per mole. So next is this partial eclipse conformation we can observe for angle 240 also. Same situation we can observe here. Methyl H and one HH. So next is this is the staggered or anti-conformation. In this staggered or anti-conformation, we can observe that relative angle between two methyl group is how much here? 180 degree. So that 180 degree angle, in that we can observe that staggered anti-conformation. So this conformation energy we have to consider to be 0 kilocalorie per mole. How much? 0 kilocalorie per mole. So energy content of this conformation 0 kilocalorie per mole. Why? Because this is the most stable conformation, more favorable conformation of n-butane. This is more favorable and more preferred conformation of n-butane molecule. That is the 0 kilocalorie per mole. That is staggered or anti-conformations. So in this way we can say that for angle 0-360 fully eclipse conformation, for angle 0-360 fully eclipse, then for angle 120 and 240 partial eclipse conformation, then for angle 180 staggered or anti-conformation, and for angle 60 and 300 for that skew or batch conformation. So in this way we can talk about the conformation that is possible in n-butane molecules. So we can also talk about the energy conformation and energy content of the conformation. That is the, we can talk like this. That is this fully eclipse conformation is the most unstable conformation, most unfavorable conformation. Energy content is 4.4 to 6.1 kilocalorie per mole. And anti or staggered conformation, most stable conformation that have the energy 0 kilocalorie per mole. We have to consider here, and related to this conformation we are consider the energy of other conformation also. So here this partial eclipse conformation have the energy 3.4 kilocalorie per mole. How much? 3.4 kilocalorie per mole. Also this skew or batch 0.8 kilocalorie per mole. So in this way we can talk also about the energy content of the conformations. So next is the graphical presentation. So with the help of graphical presentation, in graphical presentation we are going to plot the graph of potential energy of the molecule versus dihedral angle. So with dihedral angle energy content of the molecules changes, we can get the idea from graphical presentation. So graphical presentation. Representation, graphical representation. So here in this graphical representation, so we consider the x-axis or x-axis, we consider the potential energy of the molecule, and y-axis dihedral angle. Okay, so dihedral angle is 0 firstly, then 60, then 120, then 180, 240, then 300 and 360. So we consider the energy 0 kilocalorie per mole firstly, then second kind of energy possible in this n-butane 0.8 kilocalorie per mole, near about 0.8 kilocalorie per mole. Then next energy content, that is the 3.3. How much? 3.3. So 3.3 kilocalorie per mole. And last energy content that is possible in this molecule is the from 3.4 to 6.1. 3.4 to 6.1 in this range we can observe the energy content kilocalorie per mole. So you know that very well. For angle 0 we can observe which conformation, that is the fully eclipse. For a fully eclipse conformation we can observe the energy that is the 3.4 to 6.1 kilocalorie per mole. So for angle 0, fully eclipse conformation. What we call fully eclipse conformation. That is F.C. We can shortly say fully eclipse conformation have the energy 3.4 to 6.1. For angle 60, gauge conformation. What is the gauge conformation? So gauge conformation has the energy, that is the gauge. Skew or gauge conformation. Then angle 120, that is the partial eclipse. Partial eclipse have the energy, that is 3.3, near about partially eclipse conformation. Okay. Then angle 180, that is the 0. This is the most stable conformation. That is the anti-conformation or stagger conformation. Anti or stagger conformation. Angle 240, again partial eclipse conformation. Okay. Angle 300, again we can observe the skew conformation of gauge conformation. And for 360, we again observe this fully eclipse conformation. What? Fully eclipse conformation. Fully eclipse conformation. Fully eclipse conformation. Okay. This is the skew or gauge conformation. This is the anti and this is the again partially eclipse conformation. So this is the graphical presentation. With this graphical presentation, how with diagonal angle energy content of the molecule changes. So angle 60 skew, again 120 partially eclipse, for 180 anti, again 240 partially eclipse, then 300 skew conformation, and for fully eclipse conformation angle 360. So in this way we can observe the graphical presentation in n-butane molecule with the diagonal angle. So next is from this graphical presentation we get the idea, that is our n-butane molecule. In that n-butane molecule, the carbon-carbon means this carbon-carbon single bond rotation is not entirely free. Not entirely free. And also remember that our n-butane molecule exists in 70%. How much? 70% in anti or stagger conformation. Anti or stagger. Anti or stagger conformation, and 30% present in skew or gauge conformation. Okay. Suppose if we want to separate these two conformations, that time we cannot easily separate these two conformations. Why? Because that you know that very well. We only want how much energy for skew or gauge conformation? 0.8 kilocalorie per mole. So at room temperature, you know that this energy is easily available to molecule. Because of that, we cannot easily separate the anti or skew or gauge conformation from each other. And if you compare the different conformation, that time we can easily get the idea from this graphical presentation also. That is the stability order of different conformation. Stability order of conformation. Stability order of conformation. We can write here. It is anti-conformation or stagger conformation is the most stable conformation. Then skew or gauge conformation. Then partially eclipse conformation. Which conformation? Partially eclipse conformation, and then fully eclipse conformation. In this way, we can write the stability order of different conformation. So this is the most stable point. Anti, that is the 0 kilocalorie per mole. This energy content of this conformation is 0 kilocalorie per mole. Skew have the energy 0.8 kilocalorie per mole. Okay. Partial eclipse near about 3.3 or 3.4 we can write. In this range we can observe the energy. And for this full eclipse 3.4 to 6.1. In this range we can observe the energy content of the conformation. So in this way we can write the stability order of different conformation which is exist in n-butane molecule. So this is all about the conformational isomerism in n-butane molecules. So in next lecture we will discuss about the conformational isomerism in cyclohexane, means in cyclic molecules. Okay, thank you.